So let's check out number 5 here. We have 3 items. We have this binomial, that binomial, and that one. And we want to factor anything possible, and then we could circle what's in common, write it once, and then we could bring down the rest. Okay? So in the first group, what could I factor out of the 2r plus 2? 2. And if I pull out a 2, what will I have left? R plus 1. Okay? Now let's go to the next one. What could I factor out of this binomial right here? An r. And if I factor out an r, what's left? R plus 1. And in the last one, I can't really do anything, so I'm just going to leave it the way it is. But I'm going to put it in parentheses, since I see r plus 1 and all the other ones in parentheses. So, what we're going to do is circle what's in common in all groups, because there's 3 groups instead of 2 in this case. So I'm going to circle what's in common in all 3 groups, which will be this r plus 1, with this r plus 1, with this r plus 1. It's what's in common in all groups. And we're going to write it together, or we're going to write it down once. So we have an r plus 1 that we wrote down once. And what do I do with the rest? I bring it down. Right? And what is the rest? What's left over? 2 and an r. So I would put the 2r in front. You could put it in the back, whatever. But this is your LCD, or in this case your LCM. 2r times r plus 1. Again, this whole first part of the homework is just practice so you could get good at finding the LCD. So let's actually skip to, let's say number 11. Okay? We have subtraction. We need a common denominator in order for us to be able to subtract these 2 fractions. So step 1 is to factor, and then circle what's in common, write it down once, bring down everything else. So the 12, you could break it down to 4 times 3, or even 2 times 2 times 3. But the 5, you can't break it down at all to a 4, a 3, or a 2. So it's kind of pointless to factor the 12 because the 5 can't even be factored. So we're just going to leave it as 12, leave it as 5. But the x's, I am going to change them. So the first one, I'm going to leave it as 12. X times x times x times x. And the y, you just bring it down. The second one, 5x times x, y. Okay, so let's circle what's in common. And we have the x's in common. How many x's? We have 2 x's. You could circle 2 at the same time if you know that there's 2 over here. Okay, so that's 2 x's. I want to write that down one time. Okay, and then we also have y's in common, which means we have this y and one of these y's. Okay, so here's my y that's in common. And then we're going to bring down the rest. What's the rest? We have a 12 and a 5. 12 times 5 right in front. And we also have these 2 x's, x, and we also have these 2 y's, y. So our LCD, our least common denominator, is going to be 60, x to the 4th, y to the 3rd. That's your LCD. Okay, so once you know that this is your LCD, you're going to rewrite your fractions with that LCD. So your first fraction minus your second fraction, and you're going to have the 60x to the 4th, y to the 3rd as a denominator of both. So once we have that LCD, we need to ask ourselves, what do we do to the original denominator, whether it's in factored form or the original one, doesn't matter, to get this new value? How are you going to change the 12 to a 60? Well, you're going to multiply by 5, right? In addition to that, the x to the 4th is already there, but this y needs to become a y to the 3rd. So how am I going to change the y to become a y to the 3rd? Anybody? Multiply by y squared. That's right, multiply by y squared. So you're going to multiply both top and bottom by 5y squared. So what do we get as a numerator? We get 25y squared. Now on the other one, what do I do for the 5? What do I do to the 5 to get a 60? Well, I multiply it by 12. Okay? And how about this x squared? What do I do to the x squared to get an x to the 4th? Oh, I multiply it by x squared. And last but not least, do I have to do anything to the y to the 3rd to get a y to the 3rd? No. So I need to multiply both top and bottom by 12x squared. Top one I'm going to multiply by 12x squared. So I end up with 12x squared on the numerator of my second fraction. Now, ladies and gentlemen, we have two fractions right here with a common denominator, and now we're able to subtract the top with the top. So what's 25y squared? Take away 12x squared? You can't do it. They're not like terms. So you could write your answer over the common denominator. And since you can't really subtract them, yeah, you could write 25y squared minus 12x squared. I like to write it in order, alphabetical order, that is. I want to call it negative 12x squared plus 25y squared. That's your final answer for that question. All I did, this negative sign does belong to the 12x squared. That's why it's a negative 12x squared. This is a positive 25y squared. That's why it's plus 25y squared. Now, if you were able to continue factoring, do so, but we can't right here, so we're done. 15. Could you factor anything right here? No. Could you factor anything right here? No. So what's in common in both? You can't really look at them as anything being in common, not even the a's, because the a's belong to the binomial. So it's kind of like if you had the denominator 2 and 3. What's your common denominator going to be? It's going to be both of them multiplied together. So you're going to have two fractions with the a minus 3 times the a minus 5 as the LCD. So the question is, what do you do to this first denominator to change it to an a minus 3 times a minus 5? Well, you're going to have to multiply it by a minus 5. Whoops, not x, a. And what you do to the bottom, you do to the top, a minus 5 up here as well. Now, because we have a 4 up here, you're going to have to distribute 4 times a, that's 4a, and 4 times 5, that's 20 with the minus sign between them. Okay, now let's do the same to the other one. What do I do to the a minus 5 to get a minus 5 times a minus 3? We're going to have to multiply it by a minus 3. And what you do to the bottom, you do to the top, so you multiply the top by a minus 3. And you take that 9 and you distribute it. 9 times a, 9a. 9 times negative 3, that's negative 27. So now that we have a common denominator, we could write both fractions or the answer over one single common denominator. So my answer is going to be right here. All I need to do is add the top with the top. Now keep in mind that if this were a minus sign, you'd have to distribute it, make that a negative 9a, distribute it, make that a positive 27 if it were a minus sign. Because it's a plus, if you distribute it, nothing changes. So right here you could just start combining like terms. I want to combine this positive 9a with that positive 4a, that's going to be positive 13a. And then I want to combine the minus 27 with the minus 20, it's going to be a minus 47. And if you think about that's it. That's all you could do. You can't really factor the top. You can't factor out a 13. So that's it. Number 18. Let's factor the denominators first. Just to review, step 1, to get your LCD, because these obviously are different, you want a least common denominator. Step 1, completely factor the denominators. So let's do that. This top one, it's a quadratic trinomial, so all we need to do is think what times what is the last value that if you combine together is the middle value, and that'll be a negative 5 times a positive 2. And the other one's also a quadratic trinomial with a y and a y. Let's think what times what is negative 2 that if you add together is positive 1. That'll be a positive 2 times a negative 1. So that was step 1 to factor both. And now circle what's in common in both. And you might have 3, so maybe both isn't the correct word right there, but you circle what's in common in the groups. So in the first denominator, what's in common? There's a y plus 2 and there's a y plus 2. So I'm going to write my first part of my LCD as y plus 2. And then what do I do with the rest? I simply bring it down. So the y minus 5, I bring it down. and the y minus 1, I bring it down. Ladies and gentlemen, this right here is the LCD, okay? Which means that I'm going to have to rewrite both of these fractions that I'm adding with this new LCD, okay? Okay, so now I need to ask myself, how do I go from this factored form denominator to this new LCD? Well, we have the y minus 5, there's a y minus 5. We have the y plus 2, there's a y plus 2. Hey, the y minus 1 is missing. So what I want to do is, I need to put the y minus 1 down there and up here, y minus 1. At the end of it all, it's kind of insignificant to write it down here. I just want to show you that to get from these two to these three, you're missing this one. So what you do to the bottom, you do to the top. And up here, it's going to get a little bit more interesting, guys, because what do we have? We have a binomial that we need to multiply with a binomial. So we're going to have to put this in parentheses, and we're going to have to distribute. So let's first start with y times y. That's y squared, okay? And then, actually, let me show my work up here. Let me zoom in. So y times y is y squared, and then y times negative 5 is negative 5y, but then negative 1 times y, that's negative 1y, and negative 1 times negative 5 is positive 5. So when we combine the middle terms, we're going to get the quadratic trinomial y squared minus 6y plus 5. So that's what I'm going to write down as my numerator on my first fraction. Y squared minus 6y plus 5. And now let's look at the other fraction. The other fraction originally had those two binomials. The LCD has these three. So which one's missing from these two? The y minus 5 is missing. So I'm going to multiply both top and bottom by y minus 5. And up here it's pretty easy. We're just going to distribute the y. So you're going to end up with y squared minus 5y. So here are our new two fractions. I could zoom in on them. This is what we're going to be working with, these two fractions. We have an LCD, and all we need to do is add. So our answer is going to be a fraction over that LCD. And now let's simply add the numerators. So because it's a plus sign, I don't have to worry about distributing it. Nothing changes. So let's start adding. How about this y squared with that y squared? That's going to be 2y squared. And how about the y's? We have a negative 6y that we could combine with a negative 5y. That's going to be a negative 11y. And last but not least, we have the plus 5 that we just need to bring down. And that's it. And if you look at the back of the worksheet to the solutions, or the back of the notes to the solutions, this is not your final answer. And the reason is, it looks like our final answer, but you're always supposed to try and continue factoring. So maybe we could factor this top one. The a value is not 1, so it's very difficult. It's more the more time consuming. You have to do that long process. Step 1 is to multiply a times c, and that will be 10. Step 2 is to think of the multiples of 10 that combine together to give you the middle value, which happens to be negative 11. So negative 10 times negative 1, that will multiply together to give you positive 10, and it will combine together to give you the negative 11 that's over here in the middle. So that's the correct pair of numbers you want for step 2. Step 3 was rewriting your original quadratic trinomial equation, but with those two terms in the middle. And then after that, of course, factor by grouping. So from the first group, we're going to pull out a 2y, which means you'd have a y minus 5 left over. From the second group, you can't really pull out anything, but I'm going to pull out a negative 1 to make the inside value a y minus 5, which will make it exactly the same as the other one. So we're going to pull out this y minus 5 and this y minus 5. There it is on the outside. What's left is the 2y minus 1. So let's rewrite our complete answer, but instead of the above, let's write this factored form of it. There's your denominator. Let me write down the new factored form of the numerator. And now we could finally look at it and cancel out the y minus 5 that's on top with the y minus 5 that's on the bottom, which leaves you with your final answer, which is 2y minus 1 over y plus 2y minus 1.